Lesson 10.2, Graphing Complex Quadratic Functions. Our previous class was fairly straightforward, not too much going on, but now we make your life, of course, more challenging. We add a bx value. So let's just jump in and give it a shot. How do we graph 3x squared plus 12x minus 3? Well, first thing I like to do when I'm first time on this is label them. A equals 3, b equals 12, c equals negative 3. So first thing we have to do is find the axis of symmetry. The axis of symmetry is that x equals negative b over 2a. So that's just a formula, so you got to memorize that. I'll probably give it to you if it's bothering you about memorizing it. And just plug it in. Negative 12 over 2 times 3. Negative 12 over 6, negative 2. So now we know we have an axis of symmetry at negative 2, and that's x equals negative 2. It's always x. So let's do a little graphing down here. I'll probably come back up. And we said it's at negative 2, so 1, 2, vertical line. And there it is. Now, find the vertex. Take the negative 2 and plug it in to the original equation. So, what's the original equation? Y equals 3, and instead of x, put in negative 2 squared plus 12 times negative 2 minus 3. Fortunately for me, I can do this fairly quickly in my head. I get negative 15. Now it's a little tricky to put negative 15 on our graph here. It's about twice as far down. Let's call it right about there. We can extend our line down if we want. And we should label this point. This is negative 2, negative 15. Find the y-intercept, which is very easy. It's the c value. You should remember from previous time, negative 3. That it's where it hits the y-axis. It's about here. Now we're symmetrical because it's a parabola. So if we are 2 over and 3 down, we should go 2 over and 3 down, right about here. Right about here. We've graphed it. Excuse me. We've graphed it. Put it all in. Now, this one's a bit ugly, but that happens a lot when we do these more complex ones. Also like you to label this x equals negative 2. And I also like you to tell me that the vertex is either a minimum or a maximum. In this case, it's the bottom of the graph, so it's a minimum. It's a minimum point on this graph. There's more that goes up, so it's not a max. So we write minimum. Should try another on your own. You can pause the tape, try it, go through the steps. I'll do it real quick right now. Axis of symmetry, negative 12 over 2 times negative 2, negative 12 over negative 4, 3. I should label that now, but I'm not going to because I want to wait to see what else is going on. Plug it back in. I get 11. So it's up here a little ways. Call it right about there. Just I want to keep life simple. It's my vertex. It's at 3, 11. I haven't graphed anything yet, so let's see how it goes. Hits at -7. Interesting. Now we're 3 over and 7 down, so 3 over and 7 down since it's symmetrical. There's that. Now I'm going to label my line. X equals 3. It's my axis of symmetry. And since it's at the top of the graph, I'm going to call it a maximum. Again, it's ugly. Not as clean and neat as the other one. Takes a little practice too. Flipping over. Already covered this. So if your parabola does this, that's the vertex, and it's at the bottom, so it's a minimum. If your parabola does this, that's your vertex, and it's at the top, so it's a maximum. So try one more on your own. If you're confused, you should know. Change that to a y equals. Give it a shot. See if you can do it. My turn. Put in x equals -2. Plug it back in. Get 22. Right about there. And I put that dot in for later because I know it's coming. So this point is -2, 22. This is the y-intercept. Go over 2 this way, make it symmetrical, graph it down. It's a maximum. Line of symmetry is at x equals -2. Always label. Label everything. That's it. Messy stuff. Only a few steps. Get good at it. Good luck.